All right, thanks everybody for coming. This talk's big data for web application security. We both work at Etsy. My name is Mike. I'm a senior software engineer on the security team at Etsy. It's my Twitter handle. Feel free to look at my Twitter feed at some time.
How's it going, everybody? I'm Kyle.
So the slides for this talk, I just posted them to Twitter about 5 minutes ago. So if you check out my Twitter feed, which is just my name, you can follow along on your own, use the slides for whatever you want. So that'll be a good time. So I want to talk a little bit about the agenda for today's talk. Hold on 1 second. There we go. Okay. So first, I'm going to give a little background about Hadoop, MapReduce, related technologies. Is anyone here, can I get a show of hands for how many people are familiar with how Hadoop and MapReduce work? All right, so a fair bit of people. So that'll be a pretty quick set of slides. After we establish what the technologies are and how they work, we're going to speak a little bit about Etsy's specific workflow and specific key things to keep in mind when you're designing your, when you're deploying your own security mechanisms in your own data infrastructure. And then we're going to talk a little bit about the fundamental classes of web application security mechanisms, and we're going to talk about which of them can fundamentally be done in Hadoop, which of them can't fundamentally be done in Hadoop, right? The way Hadoop works, there's specific technology patterns that just don't work. So we'll talk a little bit about that, where you can start. Once we establish that, we're going to talk a little bit about some real applicable examples that we use at Etsy, ways that we've leveraged Hadoop to create security mechanisms, and hopefully those will be applicable for you and you'll be able to implement similar things. So to start off, we're going to talk a little bit about MapReduce briefly. So the idea with MapReduce is over time, disk capacity has grown rather exponentially. So like in 1998, we can store a little bit of data on drives. Now we can store a ton of data on drives. Unfortunately, over time, even though disk capacity has grown rather significantly, the rate at which that we can read data from drives hasn't grown nearly as quickly. So we can store all this data on drives now, but the rate at which we can read it off the drive hasn't really increased substantially enough for us to make good use of that. So the idea is, let's say you have a terabyte of information and it takes n seconds to read it off of a hard drive. If you take that data and split it across 10 hard drives and read it concurrently at the same time, you can read it 10 times faster. It's a linearly scalable programming model. So the more disks you add, the faster you can read all this data. And since that's not that performant, to take 1 terabyte and split it across 10 1 terabyte drives, now you can store 10 different sections. You can split them across the array of disks, and it's a good time. So that sounds great. That's really cool. So Hadoop is really great for ad hoc whole data set analysis, and it's, like I said, linearly scalable. The more, if you need your analysis to be 2 times faster, you add 2 times, you double your nodes. So it scales really easily, not that difficult. Cascading, I want to talk, is anyone familiar with cascading? Cool, so not that many people. Cascading is a framework that's built on top of Hadoop that allows for really simple development of robust data analytics jobs and queries. So previously, to write a Hadoop job, you had to do MapReduce. So you had to write a mapper that would map it across all of your worker nodes, and then you had to write a reducer that would take the results and reduce them all together and get your results. Well, that's difficult. That's kind of tedious. It's not that fun. So cascading allows you to do kind of data flow and gets rid of all that. So it allows you to do really complex workflows, or previously complex workflows, in much less lines of code. And there's way fewer barriers to entry. So it's really fun, really cool. So I'm going to hand it over to Kyle real quick, and he's going to talk about kind of Etsy's workflow and the things we do at Etsy.
Cool, thank you, Mike. So I'm going to talk about Etsy's workflow and how we use Hadoop basically to write our big data jobs. I first need to give a shout out to the awesome data team at Etsy. Me and Mike are security guys. We don't have time to set up and maintain a Hadoop cluster. So fortunately for us, we have a data team at Etsy. They set up, maintain the Hadoop cluster. They write jobs. They help out our business analysts. They can come to them. They'll give them help on writing jobs, making sure they get good results from them. and this is really important. Hopefully you have some data analysts at your company, someone that's like the Hadoop guy, maybe a data analyst that writes Hadoop jobs for you. It's important to become friends with these people, know them well, know their names, take them out for lunch, and that makes this whole process really simple and a lot quicker for you. So what this means for Etsy is we have a really quick 5-step process to write jobs and get really good output from them. It's important to make anything like this really quick and easy and repeatable. Otherwise, it's going to be a real hassle to make any sort of security mechanism happen. So the 5 steps at Etsy, real quick. You write a job. It's really simple. We're using cascading. The jobs are super small, not a lot of lines of codes. Run the job. At Etsy, we actually have a dev and production Hadoop cluster. So what this means for us is that we can run the job quickly on dev, verify that the job output is good, and then run it on prod. Step 4, commit it to our source control system. And then last but not least, schedule your job. And then you get regular data at regular intervals, super awesome. Oops. Everyone's happy. So what this means is if you don't have a simple way to go from idea to results, it's just not going to happen. You're just not going to get meaningful data. You're not going to want to do this. It's going to be a real hassle. So now everyone's happy. The team's happy. I'm going to turn it back over to Mike to talk about security mechanisms.
Cool. Thanks, Kyle. So first, if you've read the abstract, you might have seen this kind of sentence before, but basically this is like the main thesis of the presentation. This is it, right? It's difficult, if not impossible, to gain insight into the security posture of your application if you don't have a thorough understanding of your application and the events that take place within your application's ecosystem and environment, right? Like the security posture of your application is directly proportional to how much you know about your application. So in practice, there are 3 general types of security mechanisms in a typical web application environment, and that's reactive security mechanisms, proactive security mechanisms, and incident response security practices. So I'm going to go through each of those 3, kind of explain what they are, and once we have a thorough understanding of what the vernacular and the vocabulary is, we can talk about which of them are really easy to do in Hadoop, which of them are really good to do in Hadoop, and which of them are just fundamentally not able to be done in Hadoop. So the first one I want to talk about is reactive security. So basically, reactive security mechanisms usually consist of real-time event monitoring and alerting. These are security mechanisms that these security mechanisms focus on events that trigger immediate responses based on regular information querying. They're querying the same data and they're querying it often at extremely regular intervals, almost constant. In practice, some ways that we implement reactive security mechanisms are things like Splunk, right? I'm sure almost all of you are familiar with Splunk and use it regularly. It's great. It's awesome. We also use Graphite for anomaly detection, and we do that, we feed Graphite from StatsD. Are any of you familiar with Graphite and StatsD? Graphite and StatsD are really cool. Graphite's a way to display time series data, which is fed into it by StatsD, which is like a daemon for gathering statistics, which we litter in our code base. Whenever an event happens, we log a StatsD metric, and that'll say log the metric name and the time that it happened and whatever value you log for it. It could be just true, it could be whatever, and then it time series them over times. And in practice, we get really cool graphs that look like this. This is a set of graphs that we generated via StatsD and Graphite. And to generate one of those graphs takes us 3 lines of code because it's just really easy pluggable from Graphite. And it allows us to see how these critical metrics change in real time. For example, on this dashboard right here, we have logins, successful logins to failed logins, registrations, confirmations. We have tons of graph. At Etsy, we graph everything. If you've ever seen any of our operations talks, you'll know about just how much we graph things. So they're reactive security mechanisms, things you're doing now to respond to events that are happening now, right? The next kind of class of security mechanisms that I want to talk about are proactive security mechanisms. So proactive security mechanisms kind of aim to reduce attack surface or eliminate entire vulnerability classes. So these mechanisms are intended to improve the long-term security posture of the application rather than collect data about an ongoing attack or something that's happening right now. They're things we do now to protect us from compromise later. As an example, can I get a show of hands if you're familiar with content security policy? Right, so content security policy is kind of like depth for the web, right? It allows you to whitelist certain script sources and do lower your risk to cross-site scripting, right? You don't roll out content security policy because there's a huge like XSS attack going on in your application right now. It's a proactive security mechanism. You're doing it now to protect yourself later. Another thing is like full site SSL, right? Really cool screenshot of SSL. So you don't roll out SSL because you don't roll out full site SSL because you're getting man in the middle right now, some of your users in a coffee shop or something, right? You roll this out to be proactive, right? There are things you're doing as security professionals to proactively protect users within your application. Those are proactive security mechanisms. And the final general class is incident response. So web application incident response is something that we do pretty often in practice. It's not limited to when we get owned or when a full-blown compromise occurs. We often need to investigate a threat that's recently targeted organizations that are similar to our own, or if God forbid this never happens, but if a new PHP vulnerability comes out, right, we need to make sure that it hasn't been actively exploited on our system, stuff like that. So incident response is actually something that we do pretty often. And if you fundamentally think about what incident response actually is, it's ad hoc analysis of a large data set in response to a specific event or incident. Now, since the parameters of an incident are never going to be the same, they're always going to be different, you're not going to run the exact same analysis more than once. But it needs to be fast, it needs to be repeatable, and often they stay kind of similar. And we'll show examples of that in the case studies section of the talk. But basically, if we look at those security mechanism classes, those fundamental classes of web application security mechanisms, there are 4 basic ways that we can use Hadoop within a web application security environment. So reactive security mechanisms can't really be easily implemented in Hadoop. Hadoop is fast, that's the main point of Hadoop, right? But the main benefit of using Hadoop and other large data analysis infrastructure is to churn through extremely large quantities of data. For reactive security mechanisms, we want to get as close as possible to real-time results. It wouldn't be efficient or rational to run this kind of analysis on our Hadoop cluster or on any large data computing where you want whole data set analysis. It's not really a good solution for that. However, you can gather the initial data gathering for reactive security mechanisms, the predictive forecasting that you can do to create your reactive security mechanism is perfect for Hadoop. We'll get to some examples of that in a few slides. Now, so although reactive security mechanisms aren't performed on our cluster, the initial data gathering step is perfectly suited for Hadoop. Similarly, creating proactive security mechanisms, we can use predictive analysis and forecasting in Hadoop to weigh the value of our proactive security mechanisms. However, unlike reactive security mechanisms, we can use Hadoop to directly create proactive security mechanisms. The key difference here is that reactive security mechanisms are time sensitive. If you're getting attacked or if something is going on, something that you need to react to, a security mechanism is triggered and that requires a reaction, you need to react to that in real time. You need to know about that in real time because users are being affected right now. With proactive security mechanisms, oftentimes if you're going to proactively protect users, it's not imperative that you're woken up at 7:30 in the morning on a Saturday to go handle that, right? So your proactive security mechanism, since you can't really trust that you're going to get results from Hadoop at the same time all the time, you can implement proactive security mechanisms in Hadoop. It's really great. And like I said a few slides ago, incident response is ad hoc analysis of a large data set that's driven by an event or a specific incident. We're not going to do it more than once, but it needs to be repeatable. It needs to be easy and it needs to be really fast. Given all of these conditions, this is pretty much like a textbook use case for Hadoop. And we utilize it for this purpose almost constantly. So I'm going to hand it over to Kyle now, and he's going to talk about a few general ways in which we have used Hadoop to create security mechanisms at Etsy, and hopefully they're applicable for all of you as well.
All right, so I'm going to talk about some how we use big data for reactive security first. At Etsy, anytime a request comes in, we usually do a quick analysis on the data we do a quick analysis on the parameters of that query. So look for things like potential cross-site scripting, SQL injection. And then in the background, we'll do a call to statsd, which sends it to Graphite, and we have a bunch of logs on that. Based on that, we can set up an alert that will tell us if there's any anomalies in the data. And then we can use things like the whole winners algorithm that does some exponential smoothing on our data to make sure that we don't get alerted every time there's a spike. For example, only when there's a spike relative to the average volume of that metric. So right here is a good way of how we created a reactive security mechanism. However, this one isn't in Hadoop. Another great example for a reactive security mechanism is save Splunk searches or Splunk alerts. Excuse me, Splunk alerts. This is an example of a alert we have on a high number of password resets from a single IP. There's nothing really fancy about this. It's a pretty basic search, but what's important to look at right here is this little number. That is the threshold for that search. Now, where big data comes in for this one is we can use analytics to find that threshold. So if we went back to the previous slide, the number in there was 10. Why isn't it 5? Why isn't it 15? Where do we get that number from? Well, originally, it was just us basically kind of changing that number by hand. If we got an alert, like Michael said, Sunday morning, you know, you're watching cartoons, that really sucks. So you go back into Splunk, you change the number. But we can do a lot better than that. So we can write a big data job that crunches through all the password resets over a year, 2 years, high volume of data, and give us a better average number of password resets that we can use for a threshold in that search. So while we can't use Hadoop to make the, so I can't use Hadoop to make the mechanism directly, we can use it to help out us to create the actual mechanism itself. Now for proactive security, this is a really good one. At Etsy, our goal was to turn on full site SSL for all our sellers. Now you're probably wondering, all right, full site SSL, that's a security no-brainer. Well, it's not so simple. Like a lot of companies, Etsy's SSL connections are terminated at the load balancer, and back when we were doing this project, our load balancer actually had a limited number of concurrent SSL connections. So what does that mean? That means if we just turned on full site SSL overnight, flip the switch, if we hit that connection limit, we're dropping connections, we're losing money. It's bad for our sellers, it's bad for us, it's bad for everyone. So what do? Well, we need to know how much traffic on our site is actually SSL, how much of that SSL traffic is sellers, how much of it is buyers. What are the sellers doing on our site? What are the buyers doing? Where does it separate out? So what we did was we wrote a Hadoop job, actually a cascading job, to look at all our traffic on Etsy, separate it out between buyers, sellers, SSL, non-SSL, and look at the numbers. And what we found out is if we actually turned on full site SSL for all of our sellers, concurrent connections per minute divided by the traffic we had for sellers, say we turned on all those non-SSL connections to SSL, bam, we realized we can do this, we can make it happen. This is actually the job we did to do that. You can kind of see it. It looks at our access logs, kind of breaks up between seller, non-seller, SSL, and not SSL. It's actually doing a lot. It's maybe a dozen lines of code. Like I said, this is big thanks to our data team, and like Mike was talking about earlier, cascading. This makes it really like stupid, simple, easy to write a big data job, get meaningful results. It's really great. It's super awesome on this. So we rolled that out, and our sellers were happy. Proactive security, big win for everybody. Super awesome. The last security mechanism that Michael was talking about was incident response. And this one's pretty simple. Like you said, you're looking for simple patterns, URL patterns, IP addresses. If you find out a certain URL parameter in your application was target of an attack, you know, a month or two ago, a week ago, big data is perfect for this. You don't want to go grepping through terabytes of logs. You might have 100, 200 web servers. It gets really sloppy really quick. So what you can do is you can write a job in Hadoop, just go through your access logs, look for that URL pattern, find out if it's been accessed, get some data.
Yeah, and it's important to note that you're all like, most security, as the last gentleman that was up here said, most security professionals aren't professional developers. They're not, like MapReduce and Hadoop aren't technologies and frameworks that they're used to working with. And using cascading and using like a mature data workflow, writing some MapReduce jobs is as simple as a dozen lines of Ruby. I'm sure several of you have written, you can write them in Python, Ruby, Scala, several languages that you can write them, and it's really easy, it's really simple.
Right, so that means if your team, not obviously all engineers, you have everyone from the CSO to the lower level security guys writing these jobs, getting some cool results. And that's it, everyone, so thank you.